All right, so I'm gonna start recording here. I'm gonna pin my video. Okay, so this week we kind of have two topics. We're gonna go over aids to navigation. There is a ton of materials out there with aids to navigation. So I am gonna go through this PowerPoint quickly. But if you guys have a question, shout it out, let me know. Feel free, if I'm talking too fast, I can slow down. But I did really want to get to using the nav tools and plotting lat and long. So that's going to be after we get through our aids to navigation. So I am going to kind of do this quickly. We have so many people in class. I've never had this many before. So I'm kind of, anyways, yeah, okay. All right, we're gonna get started. Let's do it. So does anyone know what I'm talking about when I say aid to navigation? Give me an example of an aid to navigation.
Buoys and lights.
Buoys and lights, yes. Those are pretty much cover what we're gonna cover. So there's lots and lots of buoys and lights. And so are you guys seeing the slide?
Yeah.
I'm confused on what you're seeing. Are you seeing like where it says next slide?
Yes.
Yeah. You could be in presentation mode, and it's just going to be a slide.
Presentation mode? Display settings.
Do you have a second screen, which is just
yes, I just got a second screen.
If you go to display settings, then
Okay.
you just click on switch.
Okay.
Yeah.
There we go. Thank you, guys. Okay, so now you see the slides. Okay, and I can see you guys. So this is going to work. Okay, so lights and buoys are pretty much our aids to navigation, and there are tons and tons of different ones. So we want to know, what information are they telling us? Are they just like color coordinating with the landscape, or is everything about their shape, their lights, their colors, where they are, all of that is actually telling us something. So we want to know what that is telling us. So that is what we're going to learn. Before I get started, I think I have on the Google Classroom an aid to navigation handout or worksheet, and there are lots of quick reference materials for aids to navigation. Sometimes they're the like laminated placards that you can just keep on board. So all of this stuff might seem like a lot of information. You don't need to, completely memorize it, but having a general idea is always good. And if you have that reference sheet, you can be like, oh, I know what that buoy is because I have a quick guide, and you don't have to, look it up on your phone or something. So if you guys have those sheets, you can be looking at them while I'm going through. That might help too. Okay. So in our buoy systems, we have cardinal marks and lateral marks. Cardinal marks are going to tell us where a danger is, and lateral marks are going to tell us kind of where the channel is, or the safe water to maintain in the channel, essentially. In the lateral system, we have two systems, A and B. So depending on where you are in the world, you're going to be following A and B. So that can be confusing, because if you are taking your sailboat from Florida to Europe, you're going to be changing buoy systems from B to A. So you always want to know which one you are in. So B, us, and that's what we're going to focus on. We're all going to focus on the Ayala B system, and then you could kind of flip it back and forth if you're going to an A area. The general rule for Ayala B, which is us, is going to be red right returning. Has anyone heard that before?
Yeah.
Yes? Okay, good. That's good. So what does that mean? Somebody explain it.
When you're returning from the ocean into the harbor, you want to keep the red lights on your right-hand side, or the red signs or red buoys.
Yes, you want to keep it on your right-hand side. So that means if you are leaving, you want to keep the right ones on the left-hand side, right? Correct, I guess, and now right, left. Yes, so for us, we're always going to think of red right returning. So red is always going to be on our right side. And sometimes they can have different shapes. So another rule that we follow is, and numbers, is even red nuns have odd green cans. So we're going to talk about the buoys as numbered, even or odd, their color as red or green, and their shape as nun or can. So that's even red nuns have odd green cans. Does anyone know of another, I'm going to call it a poem or a memory aid? I always like to hear other memory aids.
I always like the one of 7-Up. It's in a green can and it's odd.
7-Up, that's good. Yeah. Green can and it's odd. I like it.
Our teacher did turn, T-E-R-N, and then cogs. So turn was like, I can't even remember. Triangle, even, returning, none, yeah. And then cogs was, I don't even know. It's can, odd, green, square, cogs.
Yeah.
Oh my gosh, you guys, sorry, there we go, I muted myself, sorry. Turn and cogs, right? Triangle,
Turn.
even, red, none, and then
cogs. Yeah.
cogs. I can't, yeah. Can, odd, green, square.
I like it. So any of those are super helpful. Whatever way you can remember it, go with that. But I would say the most common is that red right returning. So, yeah. Okay. So for Ayala A, we have our red right returning. For Ayala B. For Ayala A, we have red to red, green to green when returning. And that is talking about your own side lights to the buoy. We're going to go over this before, but for Ayala B, we have, our red on our right side for returning. On A, it's green on the right side for returning, but that shape is the same if we're going versus A and B. So the triangle or cone shape is going to be the same for being on the right side, but the color is different. Okay. So here on out, we're focusing on Ayala B, red right returning. Okay, lighthouses. So we have lighthouses, lights, and buoys. So lighthouses are obviously going to be fixed. So they are fixed to the ground. They're not affected by tide. They're not affected by anything. So if we were trying to figure out which aid to navigation to take a position or line of position from, we would prefer fixed. So these lighthouses would be our preference, and they are hopefully easily identified. So you could identify them easily on the chart and identify them easily on land, or, you know, visually identify them. So, so lighthouses are great. They can have different characteristics. If you have a coast with a lot of lighthouses, I would say our coasts don't have a ton of lighthouses, but you might be in an area that does. So the characteristics of their sectors, their actual shapes, their actual towers can all be identifying characteristics. And where do we find these identifying characteristics? In the light list.
Light list.
Light list, yes. So light list is going to have all of those identifying characteristics. You might get, you know, depending on where it is on the chart, it might just say the light and the visibility and the height, and not really more identifying characteristics. So, so light list will have a lot more. Okay. We're going to go to our buoys. So these actually are just the lateral system. We could have buoys and then also fixed objects. So our buoy, if it's green, it's going to be odd. And that is going to be on our left side as we're returning. So looking at the shape and what it's going to look like on the chart. So when you have your classically, you know, lit buoy, it doesn't have a specific shape, but it has that number on it. When you look at the chart, it will have a magenta stamp or magenta circle around it. And that means that it is lit. So that buoy symbol of the circle with the diamond, that means it's a buoy, it's floating around. And then that circle around it means it has a light. If it doesn't have a circle, so this one over here doesn't have that magenta circle around it, it does not have a light. It's just a buoy. No light. But it does give us a shape. It says it's green, and then it says its shape is a C. So that would be a can shape. And anything in quotes, so whether this is, well, it's going to be buoys, anything that has quotes around it is what is physically on the buoy itself. It's what you're going to be reading. So, for example, in Newport, we have our NWP buoy. So there's that safe water mark, that red and white buoy, right when you get out of the jetties in Newport, and it says on it NWP. So on the chart, it's going to have NWP in quotes. So anything in quotes is what you're physically looking at. And then the other symbols around it are going to give us those characteristics. So then we have our fixed, we have a fixed day beacon with a light, and then a fixed just a day beacon. Some people call them day marks. I usually call them just a day mark. And those can be, you know, triangles or squares. So on the chart, a day mark without a light is going to be a square. So it is fixed. You can use it as a, you know, for a line of position. And it's giving us that its shape is a square, it is green, and it has a number 5 on it. Then if we have if it has a light, even though it's a day beacon and it's a square, it will not have that square symbol. Because it has a light, it is a fixed light, meaning it's going to have that solid dot with a teardrop. That's the symbol that it has. the dot with a teardrop. It has a number 1 on it, and then it gives us the light characteristics. So it's flashing green every 6 seconds. That's going to be the characteristics for the light.
I have a question really fast. This might be a really stupid question, but for red light returning, this has nothing to do with like the lights, the navigational lights on your actual boat itself, the green and red ones that are up on the front on the bow. Because on the right it's green, on the left it's red. So
Correct.
when you're coming in, the red buoys are on your right side, but you still have that green light that's there, so it doesn't really matter.
Correct.
Okay.
Correct. So that's why that if I'm going back to red on returning, that means your red side light is on the red side of the channel, because those red buoys are to port, and
Right.
your side light, your red side light, is on your port side.
Okay, got it. Okay, yeah.
So, but for us in our world of Ayala B, we are not thinking about our side lights. We're only thinking about the channel.
Got it. Cool.
Okay, so this is kind of the same thing for the red side. So let's look at the shape of our nun buoy. It kind of has this angle, if you will. It does have a flat top, but it has an angle on the sides, and it's triangle, where our green buoys are can buoys. They're straight, they have parallel sides. So, and they're square, so can, square, those go together, where our nun and our triangles go together because they are angled, if you will. So same kind of thing. Buoy that is not lit has the buoy symbol. So open circle with the diamond. So a light that is fixed has a solid dot with a teardrop. Day mark, just the triangle. Lighted buoy has the buoy symbol with a magenta circle around it. Those are some more examples. So this is just, you know, that day beacon or day mark. This one is on a dolphin. That was a question that had come up. What is a dolphin? I don't really see too much day marks as dolphins. They're more for like moorings for a larger vessel. But anyway, let's go through this. Okay, so excuse me. This one is talking about as returning. If returning isn't quite as clear, if you're kind of like paralleling the coast and you're like, am I really returning? Am I not returning? I'm just like going coastwise. They give us a direction. So going clockwise around the United States. So if you're going southbound on the East Coast, westbound in the Gulf, or north on our coast here, that would be considered returning. And we're going to get into that more when we go over our intercoastal waterways. But just keep that in mind. If it's not as straightforward as seaward versus going inshore, and you're like, I'm not really going inshore, which one should I be following? Think clockwise around the United States. Okay, so now we're going to talk about some more of those lateral marks that give us information and what that means. So safe water marks are our friends. We're going to see a lot of safe water marks when we are navigating and doing our voyage plans, because you essentially want to head from one safe water mark to another safe water mark. And hopefully in the middle, it's all safe. But yeah, I think there was a question.
Yeah, Bree, there's a question from Elizabeth. Are the symbols for lighthouse and lit day marks the same?
Yes, it's a light. So it's that solid dot with a teardrop for a lighthouse and a lighted day mark. So our safe watermarks, our NWP, that one that kind of marks that entrance to the Newport Channel. So it's right in the middle, and it's kind of like if you line up with this safe watermark, everywhere around it is safe. So you could approach it from the south, you could approach it from whatever direction you're coming from. It is safe all around that safe watermark. And then you could head into the channel following your red right returning buoy systems. So if you want to go from safe watermark from LA to a safe watermark in Newport to the safe watermark, I don't think Dana Point has one, wherever else you're going. So those are kind of your good destinations to make your kind of arrival. And then as you approach into the harbor, you know, you can kind of navigate differently in a harbor versus when you're navigating from safe watermark to safe watermark, kind of just going straight from one to the other. Does that make sense? Okay. So our safe watermarks are not going to be numbered. They're going to be lettered. So there's no numbers on safe watermarks. That's one of our first clues that says, hey, this doesn't mean I have to keep this to the right or keep this to the left. I can approach this at any angle. It's saying everywhere around it is safe because there's no number. I don't have to say odd or even. It's a letter. And then the light is always going to be white. So this is another thing that I don't think it says it. Well, no, it doesn't. On our, I would say modern charts, not the training chart, all of our modern charts, it doesn't give us the color of the light. It just says the light characteristic, which in this case is Morse code A. So it's that MOA. That is the light characteristic, which is flash, 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 and then wait. Little flash, big flash, and then wait. Little flash, big flash, and then wait. That's going to be our Morse code A. So all of safe watermarks, no matter where they are going to have that same light characteristic, and it's going to be white. It's not going to be red or green or yellow. It's going to be white. On our modern charts, it doesn't give us that W. On our training charts, it will give us a W as white. So my point here is, if there's no indication of what color the light is, then you default to white. Okay. Our other main characteristic of a safe watermark is it's vertically striped red and white. So we're going to talk a little bit later about our kind of channel markers that have horizontal bands, but for our safe watermarks, they're vertically striped. So they can be all sorts of different buoy shapes. Well, not all sorts. They can be your classic buoy of what you seem like a buoy, or sphere. And but it's going to be vertically striped. Okay. Here's some examples. Okay, so this top mark, I didn't really go into that, can be on a buoy, and that gives it an extra identification, but it doesn't have to have a top mark. But here you see the little ball. That's going to be a top mark. So it looks like this, it's just like that. So any direction you're approaching it, you will see a sphere or ball shape. And then you have your radar reflector and a light, vertically striped, has letters, etc.
Quick question.
Yes.
What's the benefit of those buoys?
What's the benefit?
As in, like, what are they used for?
They're used to tell you kind of like, this is going to be the entrance to the channel.
Oh, they're just little channel markers, like the one off of Newport.
Yeah, the one off of the Newport is saying like, you can approach this buoy, all around it is safe water. So it's a safe water mark. Everywhere you approach around it is safe. You could approach it from any direction. And then as you're approaching Newport, you want to follow, red right returning. You have the red and the green lights, and then the red and the green buoys as you're approaching inside the jetty. So if you can imagine it, all fogged in, you can't see where the jetties are, you can say, I can approach this white buoy at any direction.
Right.
And even for the same as you are, exiting the harbor, you want to exit the harbor through the safe water mark and then make whatever turn you're going to make.
Okay.
So for me, it kind of starts that that new kind of navigation in your head, like, oh, I'm going from open water because I'm crossing over to Avalon, or I'm going from open water to inside a confined channel, or I'm going from inside a confined channel to open water.
Definitely. Got it. Okay.
Okay.
That makes sense.
Hey, Bree, this is Ted.
Yeah.
Are you going to touch on its secondary use as a mid-channel marker?
No, I'm not. You can touch on that. Safe water.
So where else we see the safe water mark is in traffic separation schemes and in harbor channels to mark the difference between the incoming and outgoing channel. Often they'll put a buoy like this in between the ingoing and the outgoing traffic scheme. And so it's also sometimes known as the mid-channel marker as well.
Yes. Also on that, when we look up near Long Beach, they can also kind of be called the pilot buoys because they're at the center where pilots board larger vessels. So I guess you kind of have the nickname for them, but essentially they're all safe water marks. We can look. Okay.
Aren't they, real quick, aren't they good for setting your GPS too as a waymark?
Yes.
Thing? Yeah.
Yes.
As long as you can get there safely.
Definitely. That's why I say it's great to navigate from safe water mark to safe water mark. Set it on your GPS, your voyage plan, whatever it is. But always check. We're going to go over that later. As soon as we draw a line on a chart, we check that line, see if there's anything we're running over. Okay.
Just a word of caution: there are many documented cases of delivery captains like me who have sunk vessels by using buoys as a GPS position and putting the auto helm on. So be really careful actually using the exact position of a safe water mark as your waypoint.
That's a very good point. Okay. I'm going to kind of step down to an image that I'm looking for. Okay. This is a image with a lot of buoys on it, but we're going to be talking about preferred channel. So when I talk about preferred channel, we kind of talk about we're in a channel and then we have, a Y in the road, and we could either go to the left or the right. And what the preferred channel is saying is they're preferring you to go to the right or to go to the left. Whichever one is going to be, deeper water, a preferred channel. Where you're not preferred channel, you can totally go there safely. It just depends on what kind of boat you're on, or you can put a different color buoy on your wrong side as a preferred channel if it's not the preferred one, which sometimes in our recreational boating we'd prefer to take a non-preferred channel, if you will. So let me go back to that slide. When we're looking at preferred channel marks, if your preferred channel is to port, meaning you want to treat that buoy as a red buoy. If you are coming in, I wish I had this picture on here so I can show you both of it. If you are coming in to a channel, red's right returning, right? If the preferred channel is to port and you're going to keep the red buoy on your right side, then it's going to be mostly red. So it's going to have red on the top and red on the bottom. And then it has a middle band of green, meaning if you want to treat it as a green mark, you can. You can go to the unpreferred side or channel and treat it as a green. Same with the preferred channel to starboard. So if you want to go in the preferred channel, you treat it as a green buoy because it is mostly green. If you want to go to the unpreferred channel, you can go with the red because it has both colors on it. They are going to be composite flashing. And it will have the shape, you know, angular on our reds, parallel or squared off for our greens. So that's our preferred channel. I think it'll make more sense when we go look at that other picture. These are examples of preferred channel buoys. So they have, you know, red, green, red, green, red, green, red, green, red. That one has, you know, a pointy top. This one has that squared off cylinder top. Kind of helps you identify it. Then we have our isolated danger mark. So our isolated danger, pretty much exactly what it says. It's an isolated danger. Its top marks are going to be 2 black balls, and then it's going to have black, red, black. And it is just an isolated danger. Pretty standard on that one.
How do you know which way to navigate around that? Will it be apparent, or is there, you know,
So
sometimes maybe at high water would the possibly a structure, you know, be covered, or will it just be completely apparent?
For the isolated danger,
Yeah.
it's kind of I mean, hopefully it'll say more on the chart of what that danger is, but we're going to get into cardinal marks, which do tell you which direction a danger is at. So which direction is safe passage. For the isolated danger, it's not telling you safe passage is to the north or south or wherever. So it's not telling you exactly which side. It's just kind of saying there's an isolated danger here, stay clear.
Well, by clear, what's the radius? I mean, a shipwreck can be, you know, 100 yards long.
Yes. So if it was a shipwreck, it might have something like that. It might have a cardinal mark versus an isolated danger. I guess I'm really just focusing on the word isolated. And hopefully it gives you more information on your chart of what that danger is. But cardinal marks, we're going to get to in two more slides here, maybe 3 more. And that will make more sense for you. Okay, special purpose marks can also, Ted was talking about safe water marks, marking your traffic lanes. Special purpose marks can also mark traffic lanes. They are yellow. They can mark anchorage areas. It's really just a special purpose. They can mark lots of different things. They are yellow and they have a top mark of an X is your special buoy mark. So it's really not saying, you know, this is a traffic lane or this is a military exercise area or an anchorage. It's just saying that this is a special area. You should refer to your chart or refer to something else to figure out what is special about this area. So it's giving you this kind of like, hey, yo, you need to figure something out. I'm trying to tell you something, but it's not exactly telling you, you need to keep this to the right, or you need to keep this to the left, or, you know, it's not giving you all of that detailed information. It's just kind of saying, hey, there's something special about this area. Excuse me, I'm sorry. Okay. Then we have our information buoys. So those are our, what most of the time we're going to see as our speed limit signs, or our what can I think? Like no wake zones or no swimming here kind of thing. Yeah, we're going to see those in the channel. So those are just, they're going to be white, and then have that orange red information on it. Okay, this is our cardinal mark system. So our cardinal mark is going to have one of these shapes, but you're going to have a danger, a shipwreck. Maybe it's your, you know, 100-foot long shipwreck. You're going to have a cardinal mark on top of it, and it's going to say safe passage is to the north, or safe passage is to the east, or safe passage to the south or west. So it is telling you where to go. So this is that directional buoy, if you will, where that isolated danger, that safe watermark is just kind of isn't telling you to go one way or the other by itself. You need to have another piece of information. Where this cardinal mark, cardinal buoy, is telling us to pass safe water is to the north, or safe water is to whatever direction it is. So the differences here, we have our top marks. Our top marks, 2 squares going up, safe water is to the north. When it's that diamond shape, safe water is to the east. Top marks pointing down, safe water to the south. And wine shape is your safe water is to the west. Maybe it's not wine shape per se, but some people do that. And then you also have the light characteristics, kind of like a clock. So it's quick or very quick for north, 3, flash, 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 pause, flash, flash, flash. For east, 6, and then 9. So that's our cardinal marks. Now, I'm interested to hear from you guys. I have not seen safe water marks on the West Coast here. Has anybody seen a safe water mark on the West Coast? I've seen them international multiple times, quite a few, but I don't see them on the West Coast.
Yeah, I can confirm there are none on the West Coast.
Right? I have never encountered one.
Seen one.
Okay. Just throwing that out there. Okay. So here's some safe water marks. So where would we pass on this one?
Just to clarify your words, Bree, they're not safe water marks, are they? They're cardinal marks.
They're cardinal marks. Did I say safe water mark? Sorry. They're cardinal marks.
Yeah, no worries.
You'd pass to the east of it.
Pass to the east. And what about the one on the right there?
South.
Pass to the south of it. Yep. So it also has, you know, the color banding. But I think the easiest characteristics to determine where to pass are the top marks and the light characteristics. If it's nighttime, you're not going to be able to see that top mark. You're just going to see the light. Okay. So I wish I had an actual placard, but maybe I took The only one I have right here is a celestial one, but they're like hard. I'm just gonna call it a placard. So it's just good to have one of these with the buoy systems on board if you can't remember, you know, one from another, or have the printout. Again, there's the printout on the Google Classroom. You can print that out and keep that on board, but just good to have so you can remember what these buoys are telling you. Okay, so now we're going to go to intercoastal waterways. Again, West Coast here doesn't have many intercoastal waterways. Actually, I would just say Southern California doesn't have many intercoastal waterways. Bay Area up to Stockton, definite intercoastal waterways, and Puget Sound, but they're more like going seaward or towards the harbor. But anyways, on the East Coast, there's lots of intercoastal waterways, and the Gulf Coast. So like I said before, we're going clockwise around the United States as we are increasing in number. I think I didn't say that back on our buoys. We just said we're, odd and even, but we're also increasing numbers as we go into the channel. So your 1 and 2 buoys are going to be close to that safe water mark, or, you know, at the end of the jetties. And then your 3 and 4, 5 and 6, they're going to be going into the channel. The further you go into the channel, the higher your numbers are going to be on your buoys. So if you are going on an intercoastal waterway, you're just headed, you know, you can do it actually, I guess the one that I'm thinking of is Alaska. You can go from Seattle to Ketchikan without actually going in open water. You can go the inside passage. Anyways, so the point is with the intercoastal waterways or inside passages, your buoys might not make a lot of sense. So you're kind of looking at a different shape on the buoy. So that's going to be, I'm going to go to this one first. This one makes more sense for me to explain it. So you start with your safe water mark, and then as you are approaching a channel, our reds are on our right side, our greens are on our left side, right? So our reds are even, our greens are odd. If we want to go to a unpreferred channel, we can treat this buoy as a green buoy because it has that green band on it. So we can treat it as a green buoy. So we have green, 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 and we're following this secondary channel, if you will. We also have intercoastal waterways. So if we are cruising along the coast here, so I want to say we're cruising west, but or we're cruising south or whatever orientation you can think of here. As we go into a channel here, our greens are going to be on our left side. Our reds are going to be on our right. But if we are going perpendicular to that, if we're using our intercoastal waterway, our triangles or our reds, because they're going to be pointy, are going to be on our right side, and our squares, cans, parallels, that kind of thing is going to be on our left side. So if you could kind of see this little yellow symbol on the buoy. So we're keeping, for intercoastal waterway, we're keeping the squares on our port side. So we have square, 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 even though the color and the shape of the actual buoy might be different. So you have that intercoastal waterway with the small yellow symbol on it. So if we're using an intercoastal waterway, we're following this guy, and then we do have a green on our right side, but it has that little yellow symbol on it, so we're treating it as a red buoy.
Bree, can I ask you a quick question?
Yes.
So let's say it's like really foggy and I'm
Yeah.
in the top right over there in between 1 and 3. Now I'm really confused. Like in between the green
Okay.
buoys 1 and 3. So there I am. I'm in the fog. I know I'm supposed to keep my red on the right, but if I look ahead of me, I see buoy 6 and 4, and they're on my left. How do I know if based on everything you've said thus far, if I'm right there at that point between 1 and 3, it's really foggy and I don't know the path forward, how do I use the buoy system here to indicate the direction that I should be going?
So hopefully you would have a chart, and you would know that you want to pass between buoys 6 and 8.
Okay.
Both of these buoys are going to have different characteristics. Like each one is going to have somewhat of a same, but maybe a different frequency, if you will. So you're going to correctly identify which one is 6, which one is 4, and which one is 8. So you know to pass between 4 and 6 or 6 and 8. And then the next.
On the charts, how do we know that it has like a yellow square or yellow triangle on the chart itself?
That is a good question. I do not know the answer to that. I will try to look up an example.
Yeah, Bree, so it's not marked on the chart, but you should be using a compass, and you'll know whether you're going north or south up the intercoastal waterway or not, and therefore you should be able to work it out.
So it doesn't say on the chart you're in a coastal waterway. You're just kind of, I want to say common sense, but I know none of this is common sense for a lot of us. Okay.
Well, but it's on the aid. Like if you go back on that aid, on the bottom right of that aid, there's that little breakdown of the square and on the chart. Never mind.
Okay. Okay, so this is kind of zoomed in of our intercoastal waterway. Sorry, I'm gonna read the note here. Correct, you're following, if you're on the intercoastal waterway, you're following the yellow triangles.
Yeah, to me, that's the answer to the question that he asked, is he gets confused when he's at between 1 and 3 and he sees all the reds. It tells you that you are, because at various various points along the intercoastal waterway, there's going to be another section of water that's coming in from the sea, and it'll possibly look like that with a wall of red. And so I think the key to that to me is that you have to look at the triangles and the squares more than the color. And if you're following with the triangle to your right, you should be okay.
So triangles are always on our right. Triangles are red, but sometimes they're green.
Right.
If you're on an intercoastal waterway.
So if I'm going if I'm going clockwise, keep the triangles on my right.
If you're going clockwise, correct. Okay, this is an example of it on a chart. And again, I guess that answers that question Ted answered for us. It doesn't have a certain extra characteristic on the chart to tell us for intercoastal waterway. But we have, you know, that safe watermark symbol. We have our reds. We have our bifurcation. Okay. Okay. Again, if you are in A, so if you're in Europe or somewhere else, the color is going to be different, but that shape, that pointy, is going to be the same. So pointy is always on our right. Okay, light characteristics. There are lots and lots of light characteristics. But the one thing I wanted to say is, like, what do I want to say? If it's
Hey,
flashing,
Bree, can I ask Rob here? Can I ask you a quick question?
Yes.
So the people on the intercoastal waterway, do they have to yield to ships that are in that main passage? Maybe you'll cover this later.
That is going to be a rules of the road question, and
Yeah.
it is, you shall not impede the
I'm a
passage
starboard tacker,
of a
and he's a
vessel.
port tacker in the main channel. Do I have rights over him, or does he have rights over me?
Both sailboats?
Yeah.
If you
Are there any
can
other boats?
both. Well, so the rule is going to say if you can only navigate within the channel, another boat cannot impede you. So if you are in the preferred channel because you have to be in the preferred channel, then someone crossing that channel needs to give way.
Okay. All right. Thanks.
Okay. So for light characteristics and time, that's what I want to talk about with this slide. So if we have 6, flashing twice, 6 seconds. So what that's going to look like is if you mark your time, it's going to flash twice, and then it's going to be 6 seconds later until another first flash. So if you have a first flash here and a first flash here, there's 6 seconds if that's what the interval is, or if it's 10 seconds or whatever. It's to the beginning of the characteristic, to the beginning of the next, to the repeat, if you will. So we want to correctly identify which lights we're looking at, so then we could correctly identify them on the chart. So it's really important that when you're counting, whether you're counting with a stopwatch or counting in your head and seeing how many flashes are going, that you start and stop at the beginning of each kind of cycle, if you will. If it's, too long and a short, too long and a short, or, excuse me, whatever characteristic it is, the timing is always at the beginning of the cycle. I hope that makes sense. Okay. Okay. We're going to get through this and then we'll take a break here. Determining the range of a light. So this can be very confusing for a lot of people, but there are 3 factors when we talk about determining the range. There is the intensity of the light. How bright is this light shining? Is it one of those bright LEDs, super powerful, or is it kind of that old incandescent kind of dull light? So it's how bright, how intense is that light? And that's going to be given to us as nominal range. That's what the term is for that. And that is the range that is given to us on the chart and in the light list. So that number that you see on the chart next to a light, and it says, I'm looking at one right here that just says 13M, that's its nominal range. And that's basically telling us the intensity. So the real definition of that is in perfect visibility, which according to this is 10 nautical miles. You can see that light at 13 nautical miles. Or maybe that light only has a nominal range of 5. So in perfect visibility, you can, see the mountain 10 miles out, you won't be able to see that light until it's 5 miles out. It's telling us the intensity of that light. That's what nominal range is. It's basically says how far we can see it when we're in a perfect visibility 10 nautical mile bubble. The other factor in determining your range is the meteorological visibility. So what is, you know, Dallas Rains or Liberty Chan telling us visibility is this today? Is it going to be foggy? Is it going to be clear? Is it going to be kind of hazy? So if they tell us, hey, visibility is only 5 miles, that's telling us what we can actually see. So I kind of like to think of it, if you are driving in like crazy rain or fog, you're going to see the car's headlights before you see the physical car. I don't know if there's any scuba divers out there, but when you talk about visibility under the water, you're talking about how far you can see something. So visibility is 1 nautical mile. I will be able to see that physical thing, whether, you know, that's the car or the tree or whatever it is, 1 mile away. I won't be able to see anything past that because of the haze or the fog or anything like that. But if it has a light and it has nominal range, we're going to be able to see through that fog and we're going to be able to see past that. So we're going to see it a lot sooner. So when I say visibility is only 5 miles, but we have a light, we're going to see it past 5 miles, right? If it doesn't have a light, if it's just a tree, then I'll see that tree at 5 miles, if that's what the visibility is, the meteorological visibility. So if it has a light, you're going to be able to see it quicker or further out, just like, you know, a car when you're driving on the highway and it's raining. Am I making any sense? Okay. So we have nominal range tells us our intensity. The visibility tells us visibility of the atmosphere. And then we have geographic range. So that deals with the curvature of the Earth. So geographically, can I see that over the curvature of the Earth, essentially? So let's look at these. So curvature of the Earth, this is a kind of an example of this. If we have a lighthouse, it's 150 feet tall. So from the water line to the top of the light, it's 150 feet. If I am on a small rowboat, I can only see it just past that horizon. If I am on a 30-foot boat, that extends that geographic visibility. If I'm a large ship, I can extend my visibility even more. So is the light really high? Is the light really low? Am I really high or am I really low? All of these factors come into our geographic range for the curvature of the Earth. So if you're up on the mountain, you can see a lot further than if you're down on the beach, right? If you're up on the cliff, you can see further out than if you're just standing on the jetty. So let's look at our equations. Okay, well, this is the equation. It's going to be the graph. To figure out your geographic range, you want to figure out the geographic range of the light itself, and then figure out the geographic range of your vessel, and then you add them together. Okay, that's it. So you're going to add your geographic range from the light itself and from your kind of where your horizon is and where that light's horizon is. And you add those together. So that's called height of the object and height of the observer. So you find the height of the object, what its geographic range is, and add the height of the observer and find its geographic range. Add it together, and that's your computed geographic visibility. Or if you don't have the light list, this table is in the light list. If you don't have the light list, you can use the equation, which is in Bowditch, for those of you who are testing. 1.17 times the square root of the height of the light or the height of the eye. Add them together, you get your thing. Okay, so we have geographic range. Now we're going to talk about our nominal range and what luminous range is. So nominal range, definition again, how far can we see it in perfect visibility, meaning 10 nautical miles. It really tells us the intensity of the light. So a high range or nominal range, this one is 24 and this one is 11, is going to tell us that that 24 nominal range is going to be a lot brighter of a light than that 11. So if I'm looking out at the lights and I see a really bright light and kind of a dull light, then I know that really bright light has the one with further range or further nominal range. It has more intensity. And again, that range, that nominal range, is listed in the light list, and it's also on the chart. So it's that number that has the M following it on the chart. So to find how far we can actually see it is what's called luminous range. So luminous range applies visibility that our weatherman told us and the intensity of that light, puts it together and tells us how far we're going to see that light specifically. So if it tells us we have a 3 mile, our visibility is 5.5 miles. Here's our visibility, 5.5 nautical miles. They're the curves here. And our nominal range tells us that we should see that light at 15 miles. So nominal range is down here at the bottom. I'm going to follow the 15 until it hits that curve of 5.5. Right about there. So I'm going to say my luminous range, which is when I'll actually be able to see it, is maybe I'm going to call it 9 nautical miles. Go over to the side. It's in between the 8 and the 10. So even though my nominal range told me on the chart that I'm going to see it at 15 nautical miles, with my visibility, I'm going to see it at 9 nautical miles. So for those of you who are testing, those can be some tricky questions that you need to practice. So we're not done yet. When you're looking at this, we need to figure out both. What is the geographic range and what is the luminous range? And which one is smaller? What's the limiting factor? So if I can see it physically, geographically, with the curvature of the earth, because I'm on a real tall boat and this light's real tall, but luminous range, meaning the brightness and the atmosphere is smaller, then that's going to be my limiting factor, that I'm still only going to see it whenever my luminous range tells me. If it's, a super bright light and I'm like, cool, I'm going to see this like 20 miles out, but I'm only on, a dinghy and I'm real low and this one is kind of low, I'm not going to see it until I get over that horizon. So my geographic range might be my limiting factor.
So Bree?
Yeah?
Are these calculations all things that I should do ahead of time? So, because on the chart, it tells me I'm going to see the lighthouse from, say, 3 miles away. But really, I'm in this humongous boat and I'm going to see it from 5 miles away. Should I be doing those calculations ahead of time so I know when I'm going to see that lighthouse or light of any kind?
Yes, especially if you're approaching a coastal area. You don't want to see a light that you can't identify, or if you see an aid to navigation light, not a boat, not a ship's light, and you don't think you're supposed to because there's no light around you on the chart,
right?
That should be a big old siren going off in your head. I'm not supposed to see this light. Why am I seeing the light? Where am I? I need to do some more, navigating, figuring out where I am. Or if you say, I should be seeing this light at 10 miles, but I'm seeing it at 20, there's something wrong there too. I need to figure out, maybe I'm closer to shore than I thought I was. It's just kind of doing this like double checking. You want to be able to predict what you're going to be seeing, and then what you see, validates. Yes, I know where I am. Yes, I saw that light where I thought I was. It's on the starboard side, 2 points to port, or whatever. You're validating what you think you should be seeing on the chart and what you're seeing looking out the windows.
One more quick additional question. Once you start using fancy schmancy electrical navigation, does it do those calculations for you based on your boat?
It might do geographic range, but I haven't used a ECTA system that has visibility, because visibility changes. And that's one of the things as a navigator I would always note and pass along, is especially if you're out in the middle of the ocean and you don't really know what visibility is. If you have a radar, this was always something we did, and you see a boat on radar 24 miles out, you can be looking for it and don't see it, but you see it on radar because the radar is more capable than sometimes our visibility. So then, I'd say, hey, there's going to be a boat, 2 points to port, keep an eye on it, or keep an eye over there. And then we see it. And then I look on the radar and see how far away it is. Oh, we just saw it for the first time at 8 miles out. So visibility is 8 miles. Oh. So if I'm approaching a coast, I can use my visibility as 8 miles. And my nominal range of whatever, my nominal range of 12, and my visibility was 8. So I'm going to see it at 10, or I don't know. I just made that calculation up. So.
Bree,
yes.
It's difficult for electronic nav to calculate geographical range. So typically it doesn't do it on recreational boats because there's other factors like the height of the tide at the time, and it doesn't know, if you're building an electronic navigation system, you don't know what vessel you're on or how high your bridge is and all sorts of stuff. So it's unusual. I've not seen it yet having any recreational electronic nav system giving you a calculation of geographic range for your vessel and that light.
Or any visibility of light, geographic or nearness. Yeah, that makes sense. Yeah. Yeah. Anyways, Colleen, your question was, it tells you nominal range on the chart. Yes, that's correct. So nominal range, it gives us that intensity. So in perfect viz of 10 nautical miles, it tells us how far we're going to see that light. But if it's, depending on what the weather is, we may or may not see it at whatever that nominal range is. Cool. Okay. I do an example of one. I think we've beaten this with a dead horse here. Let's take a break. So that was my quick and dirty aid to navigation lecture, and we're going to get to plotting. So let's come back at let's take 15 minutes here. So we'll come back at 8 o'clock and we're gonna plot. So get your plotting tools and your 1210 TR chart out. And we're gonna do assignments 3 and 4 if you wanted to get those out as well. So we'll come back at 8 o'clock. So I'm just going to do a brief description on our nav tools, and then we're going to get back to our PowerPoint and plotting. But I'm sure we all have different nav tools, so I'm going to kind of go over the basics of each one. So let's start with the roll plotter. So this is what I call a roll plotter. It has little metal wheels and you can roll it back and forth. So that's why I call it a roll plotter. It's very intuitive, so I do really like this one. Yeah, so let's see, I'm just going to draw a line just on our chart here. So if I had a buoy here and a buoy here, I'm just going from buoy to buoy, and I want to know what my course is. I can use my roll plotter, and for me, I like to line up, if I'm using a roll plotter, a triangle, or parallel ruler, on the black line that's parallel to the edge. Sometimes on the edge, depending on how big your plotting tool is, there can be that, like, I don't know, refraction or whatever it is. So I like to line it up on the black line that is parallel to the edge. So if I want to know what the direction of this line is, meaning the course, I have to bring it down to a compass rose. So on our roll plotter, we are dependent on where those compass roses are. So because I know this, I'm going to line up my roll plotter a little bit so it's overlapping my compass rose. So there's that compass rose. So I'm going to line up my black line on the line that I drew, and then I'm going to push down on the center of the metal part, and then you could move this paralleled back and forth however far you want. So you want to make sure you're pushing down on the center, giving equal pressure, and that's what keeps these wheels moving in parallel. So if you're only pushing on one, you might jiggle it. They have these little groupy things, so it prevents you from doing that. But just try to push down in the middle so that it's a solid movement, if you will. Because probably you're going to be on a rocking boat and have a small area that you're doing this in. So the more practice you get at home on a flat surface, not moving around, the better you'll be out there on your boat. Okay, so I have my black line lined up. I'm going to push down evenly on the center, and then I'm going to bring it down to the, sorry. So this is my compass rose. It's a little hard to see, but there's a center mark. There's like a little cross, if you will, at the center. And that's what we're bringing all of our measurements from. That's the center of the compass rose. And then for true, and that's what we're going to be going for, we're going to go to the outside circle. So if I am going in this direction, I'm going to be on somewhere on this side of the circle. So I want to make sure when I line up my line, I'm going to cross the center of the compass rose and the outer circle. So I got to the center and the outer circle. I drew a line. You don't have to draw a line. This is just to show you guys. For me, that line, I know you guys don't have the line, but for me, that line, this is 70 and this is 80. So I would call that 078 degrees going that direction. So on our compass, we have north, east, south, west. North is 0, 0, 0. That's our reference point. Everything is going to be referenced from true north. East is 0, 9, 0. That's 90 degrees clockwise from north. South is 180. That's 180 degrees from north. West, 270, if you will, 270 from north. So that big reference point we have is true north, and it has that, you know, star on the compass rose and everything. That's our main reference point, that geographical true north. And then we have east, south, and west. So, if I am going, let's say I'm going southwest, I know my number is going, my course number is going to be somewhere in between 180 and 270. So if I look at my compass rose and I got 060, that would not be the, that would be the opposite. I tried to make this a straight line. Okay, I'm not really good at straight lines there, but my point is, on our compass rose here, I read this as 078, but there's a whole nother side of the compass rose. If I was going more westerly instead of easterly, I would be in a higher digit number because of these quadrants, if you will, where if I'm anywhere between here, I'm 0 to 090, anywhere in here, 090 to 180. And hopefully, you know, if you are going northerly or southerly or easterly or westerly, so you can kind of say, hey, I want to go to the south, and, you know, San Diego is to the south. So anything in between 090 and 270 is going to be somewhat to the south, with a little more east, with a little more west, but you get what I mean, right? Okay. Back to how to use my nav tools. I'm going off on a tangent here, sorry. Roll plotter. So the con to the roll plotter, which I did the first time, I plotted, I said, okay, here's my compass rose, and here's my line. I only crossed, when I brought it down to the compass rose, the middle of the compass rose. It didn't quite make it to the edge. So then you need you can either go back and remeasure it, or use another tool, like a ruler or a straight edge, parallel it over and read it again. So sometimes it just takes a couple tries to get where exactly you want to do it, which is fine. We're all learning. But I like this one because paralleling this line to the compass rose is pretty intuitive. The only downside I have is the compass roses aren't everywhere, and sometimes you'll miss them and it can get frustrating. But we're gonna work through that frustration together. Okay, then we have our parallel rulers. So this parallel ruler has no lines on it. It's just two clear rulers that are parallel. This parallel ruler has that black line. So I prefer the one with the black line, again, just to make it that little tiny bit more accurate. So I'm same kind of thing. I'm going to line up the course that I have plotted from point A to point B on my black line. And then I'm going to parallel. So this one requires a little bit of, I call it a dance with your hands. So if you put pressure on one ruler, you can move the other ruler lightly without messing up that angle. That anywhere this angle is going to be parallel to the line that I just measured. So you can move it however far you want, and it's going to be just the same parallel. But I want to get it so it's crossing that cross and the outside circle. That's my goal here. So I do kind of the shift. So then I'm going to put pressure on the top ruler, no pressure on the bottom ruler. So I've switched kind of that anchor point. So if I keep pressure and this steady, I can move this one freely and it's still parallel. This is still parallel to my line. So if I can move this to where it crosses, let's see if I can get it. I am just about there, where it crosses my cross and the outside circle. So I am barely there, but I can read that. So you want to parallel it to the outside circle. I would say for me, the parallels are the most challenging because walking it from the line in question to the compass rose isn't quite as intuitive because it has these hinges on it, if you will. So it's not quite as a straight line as this is. It kind of goes at this angle depending on which way you're walking your rulers. But it is very intuitive, as I want to parallel this line to here. It might take you a couple tries, but you can get it there. Also, it takes coordination of the mind, right? To put pressure on one, move the other, put pressure on that one, move the other one. And I'm going to talk about jiggling a lot today, that we are all going to jiggle and have to remeasure. So same with the roll plotter. If you are moving it and it bumps into something else, then you got to bring it back and remeasure again. So the slightest bump or jiggle in any of your nav tools, we got to replot because it can change a little bit. Okay. Any questions on the roll plotter or the parallel ruler yet? Okay. And my preference is the triangle. So I know a lot of you haven't used the triangle, but it's a great tool. The big pro for the triangle is that you don't have to use a compass rose. You use a vertical line. So there are much more vertical lines on a chart than a compass rose. So for the I'm going to draw this a little bit big so you can see it. Okay, so if I have any vertical line, and those marked longitudes are the vertical lines that happen more frequently, and I want to measure this angle, you're going to put the focal point, meaning the center. So on your triangle, we always measure the line on the long side of the triangle. So here's the line in question. I'm going to put that on the long side of the triangle. Then I'm going to put that focal point on a vertical line. So I'm getting that focal point on a vertical line, and I'm lining up my course line on that black line that's parallel to the edge, just like I did with my other ones. And then without moving it, I read what it says here when it crosses the bottom of that same vertical line. So the vertical line passes the focal point, and then it passes the bottom of the triangle, and I can read that it says 0.5, we'll call it 0.56 degrees. So here is 0.50, here is 0.60, and it's about 0.56. So, and again, you can do that if your triangle is facing this way. Same measurement, 0.55, 0.56, whatever it is. So if I go back to this one, I know it's a little harder to see. You just line up. So here's my line. I'm going to put that focal point on a vertical line and the horizontal or the course line on that paralleled black line. And then I can just read what the course is on the bottom. So I feel like the big pro to this is it doesn't require any movement. That you aren't moving it and jiggling, if you will, to a compass rose. But that comes with a caveat, because if we have a vertical course line, whether it's close to south or north, and it doesn't cross through one of the longitude points, we do have to move it. So if I have a vertical line, we'll just go with the Loran line here, and it's not crossing, I do have to move it. It's not even a straight line. Okay. And how you move it is by moving it along the short sides. So you put a straight edge or another triangle typically, but you can just use a ruler or straight edge. You could honestly even use the edge of your dividers. That's another straight edge that I've used before. And you just bring that focal point to a straight edge. So for me, from here to here is a shorter move than the walking to a compass rose. But again, I am jaded. I like the triangles. But I want you guys to use whatever you're comfortable with, and I will show you any and all problems with whatever tools that you are using. For distance measurements, we have two types. We have a compass. I know it's weird because we call it a compass and there's a whole nother thing called a compass, right? But a compass has a pointy end and a pencil end. So here we can draw our arcs. So we can say, hey, I should see this buoy at 5 nautical miles. Here's my arc of visibility. Or if I get a distance, if I have a radar and can get a distance, I can use, which we are going to do in our class, use it as an LOP. It's just creating circles. That's what a compass does. Dividers have 2 pointy ends. So this is just an older pair of dividers. For this one, you just adjust the tightness here. And you could go from point A to point B. The reason I like these dividers is because they go pretty far. And then I can measure how far this distance is in between my 2 points. If you got your tools at OCC, Bar Lazarette, you probably have this guy, which you can interchange the 1 pointy end for a pencil end or make it 2 pointy ends. You could interchange them. You just turn this little knobby, if I could do it, which I cannot. Anyways, you just turn it and you pull it out and put a pencil lead in or put a pointy end in, whatever you prefer. And this is a great opportunity for you guys to try out both, see which one you prefer. Maybe you've always used 2 pointy ends. Well, try it with a pencil and a pointy, or vice versa. Do whatever feels good for you, and it's a good time to try something different that you haven't used before in practice. No pressure here. We're all going to make mistakes, including myself. Okay, those were our basic using the nav tools. Any questions on that before we get into how to plot lat and long or course and distance? Okay. Okay. Okay, we can see the PowerPoint, right? Give me a thumbs up or a nod. Okay. Okay, so for measuring latitude and longitude, again, that latitude and longitude is the most common way of communicating your position to other vessels, logging it in your logbook. It's just a quick way to communicate what your position is. So whether you're reading the lat and long of somebody else's position or you're reading it from your GPS, you want to be able to plot it on the chart, or you've plotted your position on the chart using LOPs and you want to communicate your position using lat and long. You need to translate it back to lat and long. So vice versa, we're going to be working on that. So again, latitudes are parallel, right? Latitudes are from the equator, measuring to 90 degrees at the pole, and they are all parallel to one another. 1 degree of latitude has 60 minutes. 1 minute is equal to 1 nautical mile. We're going to remember that. So minute unit, I don't know, symbol is that apostrophe, if you will, just that little tick. So here I have a measurement of 20 minutes, and it changes from kind of this darker to, that's going to be 21. It's going to be 22, 23, etc. until I see the 25. So if you're not sure what it is, find, this is 071 degrees, and then this says 5. So if this is a solid 0, I could count how many divisions I have until I get to 5. And that could kind of give me that indication of, okay, it's divided up this way. So I like to write in sometimes, the 21, the 22, the 23, etc. if that helps. But anyways, how we measure the position of this buoy, if you will. That's what we're going to be working on today in class. A few aid to navigations, we're going to be plotting what their lat and long is. So I want to know what the latitude and longitude of this buoy is. So if this is 20, how far away is this buoy from the 20-minute latitude? So whatever degree I'm at, and then 20-minute latitude, how many minutes of latitude am I away? And then same with the 071 degrees of longitude, how far away is this buoy from that line? So I'm kind of using those bold lines as reference points. So this is a picture. If I wanted to draw a parallel line, one of the most common ways to draw a parallel line, if you were to hang a picture or you're making a planter bed or whatever you are doing around the house, and you want to parallel one line to another, if you measure, 5 inches from the ceiling here, and then 5 inches from the ceiling here, 5 inches from the ceiling, 5 inches from the ceiling, and you connect all of those dots, then you're going to get a parallel line from whatever line that you were paralleling from with those measurements. So that's the basic concept of what we're doing here. So if I draw a line to the bolded lines, and then I can measure the distance, from this point to this point is going to be the same distance all the way down. So I don't have to draw giant lines all the way across the chart. We don't want to see that. We don't want to see these big lines all the way across the chart to measure latitude and long. They can just be small little dashes or ticks, okay, just to the nearest bolded latitude and longitude line. And sometimes if you're using a compass, you just put a little pencil mark, not even a line. As a beginner, I like to say, draw the line so you can see it, but don't draw it all the way across your chart. Okay, so the concept is, so the distance from this big bolded line to where the buoy is the same all the way across to the measurement. So if I want to know what latitude this is, I can use my dividers and measure that distance, and it is the same all the way across. Even if I don't have this line here, it will be the same. Same for longitude. If I measure that, distance, it will be the same longitude, the same distance all the way down to the bottom, even if I don't have that big line there, okay? So a good way to draw these lines is, let me go back to my whiteboard real quick. Okay, so I want to know where that dot is. So a good way to do this is, what is the distance here and what is the distance here? And I can bring that down and read it. And I could bring this over and read this one. So to get that line, if we draw a line, and this is why it's really hard on those Loran charts, because you have so many, the Loran overlay charts, because you have so many other lines, it can be very disorienting or deceiving, if you will, that you're like, oh yeah, this is for sure straight, and you're drawing a line that looks like that. But depending, your angle to the chart, it just can be, it can be confusing. So even if you're like, I'm totally a right angle, I can see it in my head. That's why I like to say you want to get that perpendicular line, if you will, even if it's small from the beginning, just to put that habit in your repertoire. So that is why I also like the triangles. This one clearer, I think. The triangle has a very distinguished right angle. So you can just line it up on an opposite one and draw a right angle line pretty quickly. But you can also use that arc. So if you were to, here's a dot. If you wanted the shortest possible distance, I think we have a geometry teacher here, right? Yep, that was Billy. You can do a tangent circle. So if you draw a circle where it only touches that line once, that would be your perpendicular line. That would be your right angle. So if I draw an arc where it only touches this line once, that would be my perpendicular angle. So if you are using a compass, that's another great way to do it. Or dividers, parallels, you can just parallel it over and draw the line. So yes, let's go back to my PowerPoint here. Okay, so that's this drawing is if you were to use your dividers and swing that arc. You just are getting a little tangent line. So that is measuring Latin long, whether you're given a Latin long or you are measuring a Latin long. And we will practice that momentarily after we get through this PowerPoint together. And now we're going to switch gears here and talk about course and distance. So we create these courses on our charts. The chart doesn't have, streets that we are following. If we draw, from point A to point B, whatever we've created in our head, and like I said before, the safe watermarks are great tools to use. Or whatever course we want to follow, we draw our line, and the first thing we do after we draw that line is check that line for hazards. Any line that we draw with the intention of navigating on that line, we want to check for hazards. So we want to go over that line, see what the soundings are around it, see if I'm crossing a traffic lane, if I am in a pilot area or I'm in a fishing area, if I'm kind of close to shore, just to, it doesn't have to be like, this is a hazard, you're gonna run aground if you do it. It might be, hey, we're crossing the entrance to Dana Point. There might be a lot of, small boat traffic. So just keep an eye out. So it can be anything from, hey, keep an eye out, or you are crossing land, do not go on that line. So it could be anywhere in that spectrum, right? We just want to check the road that we have just paved. Okay. In this class, and I don't know, kind of what I hear from recreational boating, we plot a lot of things from buoy to buoy. Obviously, we don't want to hit the buoy, so keep that in mind. But we use buoys. A lot of times we'll use buoys for kind of those waypoints or those changes of courses to end a road and make a turn to another road. So we go from one aid to navigation to the other. That is very helpful, useful, if you will. If you are, in hand steering and you are steering to aim for something, right? It's harder to steer by number, by 090, 089, 091, and all these numbers are going back. It's a lot harder to steer by number than it is to see a buoy or a light or the end of the jetty and just head for that. So it's a lot easier to steer. Hopefully you guys have had that experience. I don't know. By looking out on the horizon than by looking at a number. So that's another great tool of when you're plotting your course, you're plotting it for what you are looking for that aid to navigation, that buoy or whatever it is. Okay, and all of our courses, we are going to read as true. So when we are navigating on our boat and using a compass, or a magnetic compass, that is going to be a different reading than what the chart says for true. So next week, we're going to dive into the details of compass error. But for this week, all of our courses are in true. Next week, it's going to change. Okay, so measuring course. We always want to go bring it to a compass rose. So here's our parallel ruler, and we're going to parallel it up to the compass rose where it crosses that X in the middle and the outer side of the compass rose. Parallel rulers, same thing. Here we go. Here's our triangle. I think I zoomed in on this one so we could see it better than what I had. Again, you just cross it through a vertical and you see what it says on the bottom. So again, this one has, 065, 064, something like that. Also, if you guys have a triangle, you can see that the divisions, this is me selling the triangle, right? The space between these lines are spread out more than the compass rose. For those of us who have glasses or are a little hard to see sometimes, that compass rose can be so small and so hard to see. The dividers give you a little more division or accuracy, in my opinion. Okay. Okay, measuring distance. Pretty straightforward. We're just measuring from point A to point B using our dividers or our compass. And we always measure on the latitude scale because 1 minute of latitude equals 1 nautical mile, not longitude, latitude. So on these vertical sides of our chart is where the latitude is measured, even though latitude is horizontal. That's where we measure our latitude. So that's how we are going to measure our distance. If we have a longer distance, which we will in our homework, we can, our dividers won't reach. I think it's like 7.5 miles is the distance that most of our compasses can reach here. So we can get a given distance, say 5 miles. So I'll go to 5 miles and get a 5 mile, and I'll measure 5 miles, 5 miles. And then what do I have remaining? I'll just measure that and then bring it back to the edge of the chart and see what it is. And then you just add them up, and that's what the distance would be from point A to point B, even if your divider can't reach. Also, well, I guess I don't have it in here right now. That being said, and I will go over while we're doing the homework, a longer ruler or putting together a ruler and a nav tool will be helpful for going those longer distances that your plotter can't reach. Okay, so
Bree?
I demonstrated already.
Bree?
Yes.
What if you're trying to measure a distance on a vertical course line?
You would measure from point A to point B and then bring it over to the side.
Oh, with the longitude.
Not
Okay,
understanding.
Gotcha. No, I just thought that when you said referencing latitude as your measurement point to... Never mind.
Okay.
Now, I actually understand your question. I have the same one. If you're, because I'm confused about that.
Okay, so can you guys see? Let's bring this back.
If you're going straight up, what do you do?
Yep. Let me move my camera here for a second. Okay. So this is my measurements of latitude. So here I have 41:10 minutes. So this latitude line is 41 degrees 10 minutes. This latitude line is 41 degrees 20 minutes. Right? So in between here, there's 15. This is divided up. So I have 11. I have my actual pencil. Can't find it. Okay. 12, 13, 14, 15. Can you guys see that? Okay. So if I want to measure from here's a wreck to here's a buoy. I'll use the compass because you guys are using this one. I can measure from point A to point B. I get that distance on my dividers and I bring it to the vertical. So that distance, I'm just going to start at a baseline here, is going to be 5, 6, 7.1 nautical miles. If I am measuring from point A to point B, same thing. I'm just going to, on my dividers, I bring it directly over to my latitude. If I'm going east, I figure out what point A, point B is, and then I measure that distance using this scale. Does that make sense?
Yeah, totally. Thank you.
Okay. Okay, so let's pull out assignment number 3. Oh, no, sorry, hold on. Let me see. Okay, there we go. Okay, so for assignment number 3, they give us 10 buoys or significant landmarks or whatever it is, and we want to plot the lat and long. So this is just an exercise of figuring out what the latitude and longitude is. So this is also an exercise of chart familiarization because most of us don't know where these landmarks are in this East Coast area. So to avoid the frustration that I know you guys are going to have, you might want to reference the answer sheet to just give you a ballpark of where it is and then measure it. Or just ask me and I will tell you where they are. So our first one here is going to be Point Judith. So here is Point Judith. Let's see, so we have Point Judith Neck, and this is Point Judith, and we have Point Judith Light. So what is the light symbol? We're going to be doing this a lot. I'm just all over the place. Okay, so we have our light, which is a solid dot, and a buoy, which is an open dot. So we want to figure out where Point Judith Light is. And they gave us light characteristics, so I can correctly identify if there is other lights in the area. So our Point Judith Light is right there.
Is that because it's a lighthouse or no?
Yes, it's a lighthouse.
Yeah.
Okay, so let's see. I will do. I want to know what are most of you guys using? So who is using parallel rulers? You can like do a symbol on your thing. Okay. Who is using row plotter?
Use the triangle.
Okay, and who's using triangle?
Yes.
I am.
Okay.
Right here.
Honestly, most of us are using a triangle, so I'm going to start with the triangle, but I will do it on the other ones as well. Okay. Okay, so on the triangle, let me get a light. Is this one clear? Yeah. So on the triangle, I am going to do perpendicular line. So here's my light. I am going to put this perpendicular line in line with the vertical line. So I put my pencil, I put my pencil on the aid to navigation, and then I have something to bump up against. So it's a little bit easier to move around. So here's my pencil, something to bump up against, and then I'm going to line up this vertical line on that vertical line. And then I'm just going to draw, you know, a little 1-inch line there. I know it's going to be tempting to draw a line all the way across, but when you start doing that, you get way too many lines in your chart and it can be confusing if they're not labeled. You could, you know, just mark a little line there if you want, but anyways. Then you're going to do that. Trying to figure out how to do that with my camera. I'm going to move my camera. So pencil on the light in question, bump up my triangle against it. So I have, you know, something to pivot on, and I'm going to line up this you know, 90 perpendicular line with that latitude line. And now you can draw the longitude in. So now I have the latitude and longitude of my Point Judith all the way to a marked or reference latitude and longitude. So if I want to figure out latitude, the distance from my light along this line is going to be the same all the way across. So what latitude did you guys get?
Zero, 41, and 21.
0.7.
21.7 minutes north. And we are going to get into the habit of labeling with degrees, minutes, and our north. Okay, latitude is not 0, just 41. Okay, and then for longitude, see if we can see it on my, we're going to measure the distance, or how far it is from my reference longitude to my light. And I'm going to bring that all the way down from my reference point here to, this point on the chart. And I have 25, this is 26, 27, 28, 29. So for me, I'm just shy of the 29. I have 0, 7, 1, 28.9 minutes west.
I'm sorry, Bree, you lost me on the reference longitude point. Is it any line?
No, so I drew back to my light in question. I drew the closest, a line to the closest longitude, marked longitude line. So I have a marked longitude at 7130, and then my next marked longitude is here at 7120. So I
thought you said we're only drawing for an inch. I guess this is where I'm confused. What?
We did. So I went to the closest one. So my line is just about an inch. So that is what I'm going to measure here. And then I'm going to bring that down and measure it from that 30, that 7130. So this is 7130, but I am to the east of it. So how far am I to the east of it? I'm going to use my divider to measure that, and then see my 7130 and see how far to the east of it I am here. So I'm 1.1 degrees of longitude, excuse me, minutes of longitude to the east. Did that answer your question?
Yeah,
Kinda?
I got that. Okay.
Okay, let's try another one.
I have a question.
Yes.
Carol Suzuki, how do you know whether you to put north or west or east? It's all like relative, this is east of something or west of something. How do you know what denomination to use as far as the direction?
Yes, so if it's north, it's going to be north of the equator, right? That equator is our reference point for latitude. So hopefully we know if we are in the southern hemisphere or northern hemisphere, but if you're getting a position of someone around the world, you don't know. But if you have a chart, you can see the increase of numbers. So here we had 10, 11, 12, 15, 20, 25, 30. So they are increasing going up the chart. on every chart, even if you're in the southern hemisphere, north is going to be at the top. So if we were in the southern hemisphere, our chart would look like, let's say 5 degrees, 10, 11, 12, 13, etc. So 0, 9, 0, 8. So north is always up. If we are going up, it's getting smaller. That would be south. If we are in the northern hemisphere, they are getting bigger as we go closer to north. Same kind of thing if we are in the east or the west. So that reference point for longitude is the prime meridian, right? That Greenwich going through England there. So that's our reference point. If we are increasing, moving to the left, or I'm going to say, if we're increasing going west, then we are west. But if we're increasing going to the left, we are west. If we are increasing going to the right, we are east.
How did you get 41 degrees? 71 degrees. Can we go over that one really fast?
Thank you.
Yes. So the degree isn't repeated on every single one, but if you look on the side here for latitude, we have a 41 degrees 10 minutes, and then we have 15, 20, and 25.
Oh,
and it doesn't repeat the degree until we get to
the top.
The top. Yeah. So you do have to look for that degree. It only repeats the minutes.
Okay. Okay.
Same for longitude.
Yeah. I see that. That's cool. Thank you.
Yep.
Can you show me how you use the triangle again to determine the long real quick? How you drew that line?
So to draw in this longitude line, I put my pencil on the point in question, and then I bump up my triangle against it. So I have a pivot point. And then I'm going to line up that perpendicular line on the triangle to the perpendicular line, that latitude reference point.
Got it. Thank you.
Yep. So let's go parallels. If I want to draw in this latitude line for parallel, you're going to put, we're going to line up the parallel straight on a reference parallel line. So again, I like to use that black line, and then you're going to put your pencil on the point in question, bump up against it, and you could draw your line. Same with drawing in the longitude line. You're going to put your parallel right on the line, line it up nice and straight, and then roll it over and draw in your line. Same with our parallels. We're just going to move it over and draw in. Here's our parallel. Move it over, draw it in. So 60 minutes is in a degree. Less than a minute is in tenths, not 60 minutes. Helene, I think your question is in for units. So we have let's say here's, excuse me, 40 degrees of latitude, 41 degrees of latitude. So there's 40 north, 41 north. Then we have 10, 20, 30, 40, 50, 60. So then we have minutes. So this is 10 minutes, 20 minutes, 30 minutes, 40, 50, and then 60 is our next latitude line. Same for longitude. Within here, we have obviously 10. Okay, I really botched up my tenths, but here's 10, 20, divide this up into 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we'll call that one 20. So that is 11 minutes, 12, and then within this 10 to 11, we have tenths. So we have that kind of division at 5. So this is where we go to points. So
yeah, which
11.2
systems from our time-based 60s system to 10s.
Correct. Yeah. All right. Let's do number 2. Beep, beep. Okay. Number 2 is Breton Reef Light. So again, we have some buoys around here. So it says Breton Reef, and we have a light, and then we have a buoy. Here's another buoy. We want to make sure we are looking at the light. Again, that's solid dot. So here's our Breton Reef light. I'm going to use the roll plotter here. So I am going to line up my latitude line, put my pencil on the light in question, roll it up, and draw a line. Longitude, I'll line it up on a reference longitude, roll it over, and draw a line. So for me, I went the long ways. This is a lot longer than it is to this one, but my camera stand is there and I can't move it.
Hey, Bree, can you demo that on the triangle as well, please?
Yes. Okay, so for a triangle, to draw my latitude line in, I'm going to put my pencil on the light in question. Then I'm going to bump up my triangle against it. And I can move my triangle around. And so this vertical line, I'm going to line up on this close vertical line.
I'm sorry. Are you lining up the line on the triangle with a line on the map, not to the lighthouse?
So I am lining up, simplify it here. Here's the light, and then here's a vertical reference point line. So I am lining up, I'm putting my pencil on the light, and then I'm putting this vertical line of the triangle on that vertical line. And then I could draw in my latitude line. that make a little more sense, Lisa?
Yes.
Okay. So same thing when we are drawing in the longitude line. We're going to put our pencil on it, and we're going to put the vertical line of the triangle on that vertical reference point. Mine's not a straight line there, but, and then we could draw in the line. All right. So, well, for those of you who've got that one, let's go over to Gay Head. Oh, shoot. You still there? Okay, Gay Head is on Martha's Vineyard. Trying to get my cord to reach this far. Hold on. Gay Head is on Martha's Vineyard over here. So then we have Gay Head Light. Remember, a light, not a buoy. Just kidding. We're going for a buoy, not a light. Buoy 29 off of Gay Head. Okay, so here's Gay Head, and we're looking for buoy 29. So it's going to have a 29 on it. That's going to be that light right there. Pointing to it. So let's see. Let's do one I haven't done yet. We got our parallels. Parallel and lining up on a latitude line and walking it up. There we go. To a longitude. taking it. The silence is that you guys are doing good here. Working on it.
So Bree, all these answers are on your site for the
Yes.
Google work site, so we can do all of these measurements and everything and cross-check it.
Correct.
Great.
Is there a video also of you doing it?
Correct. Yes.
Okay, sweet.
So on the videos, you kind of have to scroll down through the assignments and then it says video tutorials. Where if you click on the assignment, it just has the PDFs of the assignment and the answers. You could also just YouTube Bree Bennett Coastal Nav or something, and there's the playlist. So if you go to my YouTube channel, there's a playlist for Celestial, Coastal Nav 1, Coastal Nav 2, and then my workshops. So go to Coastal Nav 1 and you'll get your tutorials on there. And if you can't find it, shoot me an email and I'll send it to you. Okay, we're gonna switch gears here and go to courses and distance. So that's assignment 4 for course and distance. I know we didn't get through much of this one, but it's a busy lecture. Okay. There we go. Okay, so for number 1, it says, what is the course from buoy 2 off of Point Judith Light to Brenton Reef Light? And it gives us there. So what is the course and what is the distance? So I want to find, first I want to find buoy 2 and Brenton Reef Light. So buoy 2 is going to be right here. And Brenton Reef Light, we already found there. So I'm going to draw a line from point A to point B. And what do I do as soon as I draw a line? My line's not even straight. I check hazards. Okay. That will be a little more accurate. Okay, so to measure course and distance, for those of you using a triangle, I want, let me do it on here. I have the buoy, and then I have a light. And this is latitude. Okay, so it looks kind of like that, right? For using the triangle, I want my focal point to cross through a vertical line and the long side of my triangle to be on the line in question. So long side of the triangle goes on the course, focal point goes on a vertical line. So I'm going to line this up like that, so that I have my course line lined up on the long side of the triangle and the focal point on the vertical.
I'm sorry, what do you mean by the focal point?
On the triangle, the lines kind of all come to a spot on the center of the triangle.
That's
on the long
focal
side.
point. Okay, thanks.
On mine, there's an actual dot there. So I'm putting the focal point and the vertical line. So let's do that actually on the chart. So I have the focal point on a vertical line and my course line on the long side of the triangle. So when I read down here, I have 030, 040, I would call 035.
You would call what 035?
The course. Then I'm navigating from buoy 2 to Bretton Reef Light. I am going to steer 035 degrees. That is my course.
Did you get that again? The 035?
Yeah.
So,
I think
we're
we all need to
looking-
hear that one, see that one again.
0, 090, 180, 270. If I am going, in this general direction, I know I'm going to be in between 0 and 090.
Right.
Right?
Yeah.
So when I line up my triangle,
Mm-hmm.
I put this line on my course line.
The black line, not the actual ruler line.
Correct. You can put the ruler side on it if you want. That works the same way. It's a parallel,
Okay.
but I find it easier to just do
Use
the
black line, yeah.
black line there. And then at the bottom here, we're going to read the course on the bottom.
Okay.
The bottom of what?
The triangle.
The
So the vertical line crosses through the focal point,
Yeah.
I see
and
it.
then it crosses through the triangle again.
Okay.
Oh, I see it. Yeah.
I
yeah.
see it now. Yeah, we didn't get that before. Sorry. I think a bunch of us didn't get that. You're
Okay.
going on the vertical to get your degrees.
Yes.
Okay, that's what we didn't understand the first time.
If I do that again on this one, I didn't draw my line.
Gotcha. Okay, that makes way more sense.
That makes yeah.
My lines aren't straight on this, but yeah. Okay. Now let's do it with a parallel. Parallel, I'm going to line up the line that is in question on my black line, and then I'm going to move it to the compass rose. So here's my compass rose. I'm going to push down and move it over till it crosses that middle point, that little X. I don't think I drew a straight line there. And I'm going to get on the outer circle between 30 and 40, so 035. With the parallels. From point A to point B, push down on one, and then you could freely move the other. I can't quite reach it, so I do have to walk it. So I'm going to put pressure on this one, move it down, put pressure on the other one, and then move close to the center of the triangle and draw my line to read what the course is. So to navigate from buoy 2 to Breton Reef, I am going to steer 035 degrees true. And then it asked me what my distance was. So we're going to see if we can reach all the way, and I think we can. From buoy to light. And then to measure that distance, we're going to go over to the side of the chart, and we measure our distance on the side of the chart. So we have 5, 6, 6.8, 6.8 nautical miles. And that is our distance.
So is it 6.8 with a tick?
No, it's going to be 6.8 with an NM.
Oh, yeah.
So that tick is going to be for latitude and longitude.
Okay, gotcha.
You could put a C for course and a D for distance. The more shorthand you do, if you just have 035 and 6.8, you can completely do that. That's fine. But my opinion is that you want to be on the same level as anybody else that's going to be looking at the chart. So on your boat, if you have, maybe a less experienced navigator, then you might want to, go CSE or write out course and degrees and true. And distance, you might want to write it out so that if for some reason you are unable to get to the chart and you're say, hey, Joe, what is the next course on the next leg? They can go down and say, and not just have our next course is 6.8, just have no idea what it is. So the better you communicate, the better it is, but you also don't want to clutter your chart with so much information that you can't read anything. So there's kind of that balance of what works for you and your crew or the people that you're working with. I want to say it also goes into like the culture of your boat. So, some companies or some types of vessels tend to abbreviate or do things in different ways. I guess I'm kind of teaching it by the book here, but there's a lot of shortcuts out there. I'm just gonna throw that out there. Okay. Let's do one more. We only have 5 minutes left here, so let's do one more. To answer your question, Colleen, yes. So if you were going from Breton Reef southwest to buoy 2, it would be that reciprocal, which is easy to see on the triangle, that 215. Okay, so our number 2, we are going from Breton Reef to buoy 11. Where's buoy 11? Oops. My camera's not gonna work for me the last 5 minutes. Okay. Buoy 11 is off of Bull Point 21. Oh. Jeez Louise. Let's take this down. Why is it not working? Okay, we're having technical difficulties here.
Can anyone find buoy 11 while she's fixing the camera?
Buoy 11 is going to be north, slightly east.
It's that purple dot, right?
It's going to be the buoy. What number are we looking at? Buoy 11 is going to be that purple, the one that has a light.
Purple dot just a little bit to the right.
Yeah, it's entrance to the bay.
Lose your camera, Bree.
Right where the white and the blue meet.
Almost, yeah.
That little channel.
Yeah, where the channel is labeled East Passage.
Uh-huh.
Okay, I'm not getting my camera to work. Dang it. Well, this was at the very end. I will get a camera working for next week. Sorry about that. So we are hopefully drawing. I'm going to talk us through it here. Drawing from Brenton Leaf to that buoy 11, which is going to be northeast of Brenton Reef. It's in the little channel there. If we draw a straight line, after we draw a straight line, we always check for hazards. And this one's big. There's land, right? So, hey, we can't go straight there. We're going to have a little dog leg, a little course change along the way. But just to practice our skills here, we can measure what the course and distance will be. And then it says, would it be wise to steer a course on a straight line? The answer is no, it would not. We are going to run into Castle Hill. So really get in the habit of each course that you draw for this homework assignment, you check it and check what the hazards are. And again, I say hazards, but it doesn't have to be a hazard. It can just be a, hey, there might be a lot of boats in this area, or there might be a lot of like kelp and I'm on a sailboat and I don't want to go through the kelp, or anything and everything, right? We just want to know what we're going to be getting ourselves into. So that's all I got for you guys this week. Again, I apologize for my camera. I will figure that out for next week. Check out the answers on the Google Classroom and the videos. If you get stuck on something, you can email me. I'm happy to do another Zoom and just walk you through it. And again, I come on at 5:30. So if you want to jump on and practice earlier next Wednesday, that works too. Next week, we're going to be diving into compass error. So the difference between what we read on the chart and what we're going to be steering on our boat. So we're going to practice that in some worksheets as well as practicing it on the chart. And next week is, I'm pretty sure next week is going to be the Long Beach, the 18746 chart. So, so we won't be doing the training chart on that one. But yeah.